Yeah, good evening all. In the last class, I was discussing about general Databricks, Azure Databricks, why Azure Databricks, and Apache Spark, need for PySpark, PySpark features, job market of Azure Databricks, right? Yes. So Databricks provides a Spark cluster. A cluster is a group of nodes connected in a network. We see two types of node, driver node and worker node. So you can have multiple worker nodes, one driver node. So Spark is a very high-speed processing execution model which process huge data in quick time. Mainly, we have got in-memory computation, storage and processing happening within the memory level, right? Massive parallel processing. It's 100 times faster than normal disk processing. If you have got some hundreds of clusters, processing 1 TB of data at a time. Tomorrow, if your data volume increased, so the speed is going to decrease. If same cluster use, speed goes down. The solution is scaling up the cluster by adding new nodes to it. So again, after 1 month, again, if data increased, scaling up your physical data center. The solution is same cluster in the cloud, the two with auto scaling feature provided by Databricks. Databricks provides Spark cluster with auto scaling feature. So if organization data load requires 100 nodes, if data volume increased, automatically it has to extend to 200 automatically. After processing is completed, again it has to revert back to 100 nodes. This is general Databricks, which is not compatible with all the Azure storage services. Means like Azure SQL, Azure Data Lake, Azure Synapse, Cosmos. Databricks is available for not only for Azure, for also for AWS and Google. So regular Databricks is not compatible with all the storage. So Microsoft and Databricks collaboratively, they launched a new product called Azure Databricks that has got the auto scaling feature and compatible with all the Azure storage services. It can interact with all the Azure storage services. For normal Databricks also you can do, but with lot of other settings, we need to call many other APIs. So in Databricks, who is processing the data? Spark. Spark is the main, right? Is the execution engine. And Azure Databricks is a Spark-based data analytics platform. So it is I can define Spark. It is an open source distributed cluster computing framework, in-memory computing feature with parallel processing style used for large-scale data processing. Why PySpark means it is a Python API to use Spark. So PySpark is this lightning fast technology that is designed for fast computation. It's a demanding tool among the data engineers to work with bigger data sets. So it is mainly used for distributed SQL, creating data pipelines, ingesting data in databases, running ML algorithms, running graph algorithms, that is working with the graph algorithms and with the data streams. Yes, a need for PySpark for extracting valuable information from the raw data, right? A real life use cases of PySpark I was discussing, right? So in Databricks, The main execution is a Spark. There is a Spark with Python implementation, right? Spark with Python implementation. So here, the Spark mainly used in the commercial sector, in banking and financial fields, in healthcare, and in entertainment industry like Netflix using Spark, and trading and e-commerce like Flipkart and Amazon, they're using Spark for advertising, and in tourism industry and many more, right? Yes. This is what we have discussed in the yesterday demo session, right? Yes. Fine. If anyone have missed the yesterday session, right, you can check the video that will be kept in the chart panel after 10 minutes, right? The Zoom chart. Fine. So most of them, they see the difference between Azure Data Factory and Databricks. Azure Data Factory. What Azure Data Factory? Azure, this is ADF. ADF. We won't write any codings here in ADF. Azure Databricks. Azure Databricks. Azure Databricks. ADB. Okay. The main purpose of this. Azure Data Factory. It acts as data integration. What is that? Data integration service. What do you mean by data integration service? Data integration service, or we can say data orchestration service, or orchestration service, we say. Orchestration service, right? So data integration means, see, databases are there. Generally, whatever you are performing transactions, everything stored in the database level. So if you want to bring that data, if you want to bring the transactions to warehouse, to want to bring that from different databases, you want to pull the data, you want to bring the data into data warehouse, we use this ADF. ADF is good, it acts as a ETL, extract, transform, and load. So between these OLTP systems, online transactional processing, that is databases, between the databases and data warehouse, in the middle, you see this data factory as a data integration service. So just check this. Data Azure Data Factory is a cloud-based ETL. If you observe this, generally transactions happens at this OLTP, different OLTPs. So you are using Oracle, MySQL, DB2, SQL Server, and here in the cloud side we use Azure SQL, right? Azure SQL. So here data warehouse, DWH, data warehouse, like we have got like Teradata, Netezza, Vertica, Teradata, Netezza, Vertica, and if you see here, right, Azure Synapse. So here ADF, right? It's going to extract the data from this and loading the data, right? Loading data into this Azure Synapse or Azure storage lake, data lake storage, right? So here it acts as a data integration service. In the middle, you can see between this OLTP databases and data warehouse, it acts as a data integration service. And what do you mean by orchestration service? What do you mean by orchestration service? Means in the earlier versions of Azure Data Factory, you need to have the lot of knowledge about different things like stored procedures, like Hadoop, Apache, Pig, and many other things, right? Means in Azure Data Factory in the version 1, there were no inbuilt transformations. There were no inbuilt transformations. But if you want to perform transformations using Apache Pig, it's a data flow language. Using Apache Pig or USQL, it's not similar to SQL. Using Apache Pig, using USQL, or using stored procedures, and using Azure functions. Using all this used to perform the transformations, whatever Azure. But from this from ADF version 2 onwards, no need to have the knowledge about this Pig or USQL or stored procedures or Azure functions, right? It acts as a orchestration service. Like orchestration service means whenever whatever transformations required, it is going to trigger those. So inbuilt, you got a lot of inbuilt transformations. Based on that transformation, it is going to take that service. Whichever required at that time, it is going to trigger. That is what orchestration service. So Azure Data Factory, the main thing is data integration service, orchestration. That main thing is it performs cloud ETL. What is that? Cloud ETL. Azure Data Factory is a cloud ETL or cloud-based ETL. So if you come to this Azure Databricks performing big data analytics, for huge data. So for huge data processing, right? That's why we are going to here in the case of ADF, we cannot control the cluster. We can not control here in both in ADF and in Azure Databricks. Yesterday I was discussing, right? A cluster. We need to have a cluster, means a group of systems connected, interconnected, multiple systems which are interconnected. In that one will be the driver, remaining all will be the worker. So if you talk data, for example, okay, purpose or this primary function. And here data transformation, if I talk about the data transformation. In the case of Azure Data Factory, basic transformations you can go. Basic transformations, inbuilt transformations available. You no need to write any code. Basic transformations. Using what? You basic transformations using data flows. And a mapping. Data transformation, right? Basic transformations using data flows and mapping. So here in the case of Azure Databricks, advanced transformations using Apache Spark. So the main thing here in Apache Spark also we have got a concept of data frames. In the data frames, many functionalities, data frame functions are available for performing the task. And also if you want to deal with machine learning, or if you want to deal with streaming, or if you want to deal with the graphs. But in the case of Azure Data Factory, if you want to work with, we doesn't have that much powerful transformations for working with graph data, or working with streaming, or working with ML algorithms, right? We doesn't have that much of advanced transformations. But here we have got like advanced transformations because Spark is providing many libraries, right? For machine learning, MLlib is there. Spark MLlib for streaming, and for graphics, Spark SQL is available, Spark core processing is available, right? Yes, and that too with a very high rate of speed. So if we talk about the development interface, how we are going to develop development interface? Development interface, right? Graphical user interface. Here, graphical, everything is a graphical user interface. Graphical user interface. GUI, everything drag and drop you see here for creating pipelines. Here, everything is creating pipelines. Creating pipelines. But here in the case of Databricks, we have got that notebooks. We'll be create notebooks here. We doesn't have any like drag and drop kind of things here. Notebooks for interactive. Notebooks for interactive data analysis and development. Yes. Graphical user interface for creating pipelines, notebooks for interactive data analysis and development. And here, scalability. So directly, it's not possible, right? It scales through integration with other Azure services. And also here, default cluster. Default cluster. And we have cluster here. In the case of Databricks, highly scalable. Highly scalable. Highly, what do you mean by scalable? We can keep on, means just now I was telling right, with auto scaling feature, whenever your data volume increase, your number of systems should has to increase. Auto scaling feature, right? It is highly scalable with many inbuilt Spark clusters. With built-in Spark cluster. Here we have got in data Azure Databricks, we have got the provision to create your own cluster with your whatever features, configurations you want, capacity, right? Everything. But here in ADF, default cluster. Built-in Spark clusters. So mainly, okay, zero coding ETL, ADF is a zero coding ETL, no coding is involved. So here also we have got transformations, many built-in transformations available. In Azure Data Factory, many built-in transformations. In the data flows, we have got the version 2, especially in the ADF version 2, we have got the concept of data flows and power queries, which are powerful transformations, inbuilt transformations, which you won't see in version 1. In version 1, you need to have a lot of other knowledge like big data, Hadoop, like Apache Pig and USQL, and also like Azure functions and stored procedures, lot of other knowledge. But from version 2 onwards, it was very flexible with powerful transformations. Okay, but compared to that Azure Databricks, you can write your customized code. You can write the code here in Azure Data Factory. You will be everything drag and drop. But here for writing this customized code, right, in Azure Databricks through notebooks, performing data analytics, especially for big data analytics, right? Databricks will be the one of the best choice, and total execution happening through Spark, everything happening through Spark. So if we talk just little history on Spark. So if we talk about the evolution of Apache Spark, because that execution weapon here is Spark. Evolution of Spark. Spark was developed by Matai Zaharia. EMP Lab, Berkeley. Spark was developed by Matai Zaharia in AMP Lab, Berkeley in the year 2009. Spark was open sourced. Spark was open sourced in the year 2010. It was made open source in the year 2010 and it was donated. Spark was donated to Apache Software Foundation. Spark was donated. Apache Software Foundation in the year 2013. So it was introduced in the year 2009. It was open sourced in the year 2010. It was donated to Apache Software Foundation in the year 2013. So already I was saying defining Spark, it is an open source, parallel processing, in-memory computing, all right? Large scale, it's used for large scale data processing. Here I was saying you're right, yes. Here Spark is an open source distributed cluster with in-memory computation, parallel process. See, what do you mean by in-memory computation? The main thing is in-memory computation. So here, if I talk about in-memory computation, what do you mean by in-memory computation? Defining Spark. I will define Spark in 5 lines. Spark is an open source distributed cluster computing framework or execution framework with in-memory computing feature, parallel process used for large-scale data processing, mainly in-memory computation. In-memory computation. In-memory computation means here data gets divided. Data gets divided into multiple partitions. And are distributed across multiple RAMs. Multiple worker nodes and are processed parallelly because of which we see very high speed. Yes, data gets divided into multiple partitions and distributed across multiple RAMs of multiple worker nodes, because of which we get very high speed here. Okay, do you see any, okay, um, other in-memory computing systems, do you see any other in-memory computing systems in the market? Just like other than Spark, other in-memory computing systems. Yes, sir. SAP HANA. SAP HANA you can see. But SAP HANA, you won't see distributed RAM here. But in SAP HANA, we won't see distributed RAM. Distributed RAM like Spark. We won't see distributed RAM like Spark. So Spark has high speed. Spark has high speed because of distributed RAM. Distributed RAM. Because of distributed RAM. Other in-memory computing systems, SAP HANA, but we won't see distributed RAM like Spark. So here Spark has got high speed because of distributed RAM. So RAM speed as compared RAM processing, storing within the RAM and processing within the RAM will have high speed. So here mainly I said here we are dealing with the PySpark. Spark with Python implementation, right? Spark can also be implemented or coded with.
Hi Vijay, I have one doubt here.
Yes.
In SAP HANA also we have like driver and master. We have nodes, right? Like driver and worker nodes. That will also work as a distributed, right? There also we have a number of clusters. I mean, one group of computers connected, right? You mean like you are saying it's not distributed Snap HANA?
Means
We can't auto scale.
so here generally here data gets into partitions. In Spark, data, whatever your Spark data objects will be divided into partitions. And the what a big data we here whatever we deal with huge data objects generally in the Spark generally is for batch processing, not for it's for batch processing, batch applications where we deal with huge data objects like TBs of data. So that will be divided into smaller partitions. They'll be divided into smaller partitions and they are going to that single data object divided into multiple partitions getting distributed across multiple RAMs here and are processed parallelly. So here a single data object processed by multiple systems, multiple worker nodes. That too, they are stored and processed within the RAM level, right? So in the case of Hadoop, like disk level processing happens. Not like we don't see in the case of Hadoop also, which can maintain huge data, but not in-memory computation is not possible in the case of Hadoop. In the Spark, in-memory computation is possible. So yes, in the case of okay, if you are maintaining, yes, you are saying that in the case of SAP HANA, if you are maintaining, okay, you are maintaining some 10 nodes. Assume that you have got 10 nodes, one driver and 9 worker nodes. What happens? Here, one thing is highly scalable. Yes, Spark is highly scalable, right? You can keep on increasing, auto scaling. But what happens here? Think that uh, daily 1 TB data is coming. Daily 1 TB data is coming. Maximum, if you got 10 systems, each one is having like think that some 1 TB, 1 TB, 1 TB, maximum it can accommodate 10 TB, 10 systems. Daily 1 TB is coming, maximum 10 TB data, it can accommodate. 11th day, in the case of SAP
Okay.
HANA, 10 days, okay, daily it can accommodate 10 TB, 10 systems, each system 1 TB. If you think 10 days, okay. 11th day, it has to remove the data of, it has to get, data has to be removed or 11th day data.
Yeah, you should remove data. put on
Yes,
it.
yes.
We do not
But
have
in
the
the
size of
but in the
support.
case of Spark, the advantage is auto scaling feature you can see with depending of the incoming data, distributed storage, parallel processing you can see, and that too with in-memory computing feature. And you can keep on scaling, auto scaling. That is what auto scaling feature. That's why Spark has got great demand today. Just I'll compare with other technologies also. Why Spark has got other in-memory computing means, yes, we have got other in-memory computing systems also, but
Okay, thanks.
compared to SAP HANA, Spark speed will be more. And okay, Spark can be implemented or coded with Scala, Python, multi-language support, Python, Java, or language. Frankly speaking, right? Spark by default built using Scala language. Spark by default, it is built by using Scala language. Scala is the native language of Spark. Most of the Spark functionalities using Scala, they are built. But okay, when Spark was introduced, Spark was developed, even if you see, go back like 8 years back, Scala is the most, Spark with Scala is mostly preferred. Means if 2016, 17, 18, because Spark by default, it's a native language, Scala is that. But today, like Spark with Python has got great demand because of Python has got many libraries, thousands of libraries Python is providing, right? Means if you are combining Python and Spark, so Python is providing an API. Python is providing a API called PySpark. Python plus Spark combinedly, right? Yes, PySpark. So it has Python is providing an API called PySpark, where it is providing many libraries, especially Python as compared with Scala and Java. Why Python has got great demand today? Because Python has got powerful libraries for data analytics. If you talk about the word data, whether it is data science or data analytics or data engineering or data analyst, Python is the mostly preferred language. Right? If you talk about data science, ML, machine learning, deep learning, AI, for all this, mostly preferred language is Python, right? So that's why Python, as it has got many models like NumPy, CP, Pandas, Matplotlib, right? Scikit-learn, right? In this way, it has provided many models, thousands of models it has got. So because of it, Python is mostly chosen. And that too, Python has got a greater community, a big community it has got as compared with Scala. Means Java also, I'm not saying that Java also can be used, can be implemented, can be used. But in the industry, Python and Scala are the mostly used. Python and Scala is the mostly used. Java is never preferred, and that too because of huge codings in Java, lot of codings in Java, like lot of packages we need to import. That's why today in the industry, previously Scala was used. Even today also Scala is used. Apart from that, Python is the mostly used, especially for this whatever we are discussing, right? Databricks with that Spark with Python is the better suited one. Even most of the projects we see, right, is for Python, Spark using Python like PySpark, right? And also one more language also, Spark. That's why Spark is providing multi-language support, even our language also, right? So, but here in our course, like Spark with Python, like PySpark, we'll be discussing, I said, Azure Databricks with PySpark. So by default, Spark built using Scala. So previously there was one technology like if you talk Tej, Tej and Spark, Tej and Spark, right? If you compare this both the technologies, both the So we have got a technology like Tej and comparing Tej and Spark, right? Yes. The commonality between these two, is both follows the DAG model. Both follows DAG model, directed acyclic graph. DAG means directed acyclic graph. Both follows directed acyclic graph model, right? Yes. But okay, both model directed acyclic graph model means generally if you see data flow, Spark is a data flow language. See, the output of one will be the input to the next flow. The output of this will be the input next flow. So directed acyclic graph model you see. But the difference is Tej doesn't support. Tej doesn't support in-memory computation. In-memory computation. It doesn't support in-memory computation. So Spark has got high speed. Spark has high speed as compared with Tej. And if you talk about Spark comparison with other technologies like Spark and Hadoop MR, we say Hadoop MapReduce. Hadoop MR means Hadoop MapReduce. People who have knowledge on this Hadoop MapReduce, right? Here drawbacks.
Vijay,
Drawbacks.
one doubt here. See, if you go to Sapana and Tej, right? Sapana, we are saying like it won't support distributed RAM. If you come to Tej, we are saying it's in-memory computation.
It's not in
Uh,
memory.
sorry, it's not in-memory computation means it won't support the distributed RAM. Tej will not
So
support the distributed.
in-memory computation means both storing and processing within the RAM level not happens in Tej. Storing means data storage in that RAM and processing within the RAM won't happen in Tej.
Okay, in Sapana, data storage is possible, but I
It's
mean,
not you won't it is not highly scalable.
it's only auto scalable will not support. Oh, but we have the driver and worker nodes. They,
Yes,
Sapana.
yes. And
Okay.
if we talk about Hadoop performs all those, but Hadoop drawbacks with Hadoop MR means as compared to Spark. Here, in the case of Spark, transformations you can reuse, but here transformations you cannot reuse. Cannot be reused. In Spark, you can reuse the transformations. Bad for iterative algorithms. Iterative algorithms means most of the, if you talk about this ML machine learning algorithms, they are iterative in nature. Means if you are performing some analysis or prediction, if you are applying some algorithm on a particular data, you will get some error, some prediction it does. Yes. For iterative algorithms, previously there was a component called Mahout, but it is bad for iterative algorithms means ML algorithms means iterative in nature. You keep on applying, keep on applying. For example, very simple. A prediction algorithm, if you take, if I want to predict your age, assume that your age is 30. My prediction was 40. You see that what is the difference error between them? 10. Again, once again, if I predict, this time my prediction is 35. but actual age is 30. Again, if I apply, this time I'm predicting 32. Finally, I'm saying 30. Means you keep on applying until the error becomes 0. That is what iterative nature. Generally, most of the algorithms, right, will be iterative. But this is bad for iterative. But Spark is good for iterative algorithms. It has got separate library available, right? MLlib library. Not a flexible parallel process. Not a flexible parallel process. But here parallel processing in Spark. You can control the parallel processing if you want to increase, or if you want to increase the more parallel process I can increase it in the case of Spark. In the case of Hadoop, you cannot increase the parallel processing further. If you have got more number of systems available, I want to increase it further to make use of all the systems. I can make use in the case of Spark, but in Hadoop not possible. Spark is 100 times faster. Spark is 100 times faster than Hadoop MR. Spark is 100 times faster than Hadoop. Have you seen the speed of Hadoop first? See here, Yahoo. It has conducted a test to check the speed of different databases. It has taken a table of 100 TB consisting of 1024 columns. Task is sorting based on 16 columns. Spark based sorting based on 16 columns. Time taken, see the time taken, right? Time taken by, okay, if we talk about the different databases and their speed, right? Oracle, right? Oracle, it has taken nearly 3.5 days to process. MySQL, it has taken 6 days. MySQL, 6 days. But you have got some specialized databases used for data warehouse like Teradata, which can handle TBs of data. Just it has taken 4.5 hours. One more specialized database like Netija, it has just taken 3 hours. And finally, Hadoop, it has just taken not days or hours, minutes, 3.4 minutes it has taken. That is Hadoop speed as compared with this, right? Which has taken days and hours, but Hadoop has taken minutes. Spark is 100 times faster, means see the Spark is 100 times faster than Hadoop MR. See the speed of Spark then, right? Very high speed as compared with this. So even there is one more Spark was introduced by Apache only. Apache Spark. Just now I was talking about there is a technology called Apache Pig in Hadoop. Apache Pig. Both are data flow languages. Both are data flow languages. The output of one will be the output to the next. In this way, output of one will be the input to the next flow. Both are data flow languages. But in Pig, entire data flow, as Apache Pig is a component of Hadoop, entire data flow will be converted Hadoop MR job. Just now we have seen, right? Okay, Hadoop MR, The drawbacks of Hadoop MR we have seen. Hadoop MR has got drawbacks, right? So even Pig also get the same drawbacks. So if you see Apache Pig is a very, so if you see Apache Pig, it was a hot cake in the market when it was introduced 10 years ago, right? If you see 10 years or 2012, 13, 14, 15, was a hot cake in the market because Apache Pig 100 lines of Java code, we can write within 6 to 8 lines in Pig using Pig Latin language. It was that much flexible Apache Pig. But once Spark was introduced, Apache Pig got outdated. Mostly Pig with very less coding. We used to write many Pig scripts. But when Spark introduced, this Apache Pig got outdated as it is using MR, entire data flow converted into Hadoop MR chart. And again, MR has got drawbacks. And if you compare Spark with Apache Spark, Apache Flink, most of the people, right, if you go back like 6 to 7 years in 2017, 18, Flink, they said Flink was dominating Spark. Flink was dominating Spark. And say this most there was a they were saying that now Spark will be away from the market as Flink was dominating Spark. Yes, it was correct. So in the initial versions of Spark, in the initial versions of Spark, in the initial versions of Spark, Spark was weaker. Spark was weaker in data analytics. So Apache Flink was dominating Spark at that time, right? When both are Apache products, both purpose and objective is same, both were introduced by Apache only. But first Spark was introduced, next immediately Flink was introduced. Flink was dominating Spark. So, but in the Spark 1.6 version, before Spark 1.6, before Spark 1.6, Flink was dominating from Spark 1.6, from Spark 1.6. So it came with powerful libraries. From Spark 1.6 onwards, Spark came with powerful libraries for data analytics, for streaming, for graph algorithms, right? It almost became equal, right? But from Spark 2 onwards, but from Spark 2 version onwards, Spark dominated Flink. There's a lot of powerful libraries, right? For all these things was introduced. So it was dominating Flink. Now you won't see that. You won't hear the word Flink now. But in the initial days, Flink was dominating because Spark was weaker. But slowly, as version to version, some powerful libraries were introduced, especially for data analytics, for streaming, for graph algorithms, that it was dominating Flink. So if you're comparing with other technologies like a Spark with Apache Flink, Spark with Apache Pig, a Spark with Tej, a Spark with MapReduce, Spark with HANA, right? We see Spark has got a higher speed, very high speed, right, as compared with other things. Even so, Spark has got great boom today. So that too in Azure Databricks, the main execution engine is Spark. So even if you see job market of this Apache Spark with Python, PySpark, if you have got knowledge, right? So you have got bigger packages, salary packages, and also if you can see the calls, you have got lot of calls for this Azure Databricks with PySpark addition to PySpark, right? Yes, generally I'll be discussing point to point from basics to the advanced level. So even I said I'll be discussing about PySpark, Azure Databricks and PySpark as compared to other training sites, right? So here I'm having separate batches for PySpark, and here I'm taking separate batches for PySpark, Spark with Scala, and also with this Databricks with the PySpark. So in brief, in depth, I'll be discussing about this. So you can just go through that course content, right? Once. Azure Databricks, what is introduction to this big data and Hadoop? You need to have some knowledge because you need to, what is a cluster? Yes, just now. Yes, Mahesh, right? Yeah, those all that prerequisites like introduction to this big data, Hadoop, Spark. Before I go with the actual, right? Databricks, I'll be discussing about the prerequisites. Those who are new to this, Azure Databricks architecture, main concepts like Databricks service using ARM, Azure Resource Manager, adding users and groups, creating cluster, and how do you create clusters, manage cluster, displaying cluster, starting cluster, terminating cluster, delete a cluster, because here you can have total control on the cluster. Cluster information, cluster logs, access control, and what are the different types of cluster, Databricks pools, cluster modes, auto scaling, Databricks runtime versions, multi-users clusters, Databricks different utilities, each one of the data utility, file system, job, library, notebook, secret, limitations, and Databricks integrations with this data lake, blob storage, Azure SQL database, Synapse, Snowflake, working with different types of file formats, CSV, JSON, Parquet, Excel, XML, ORC, Avro, Databricks batch processing, totally in Spark, we see in PySpark, right? Totally, we see batch applications, batch processing, historical data load, incremental data load, date transformations. We have got many functionalities, aggregations, join operations, window functions, union operations, or apart from that, Databricks streaming API. What is streaming? Process streaming with PySpark API, handling backed records, streaming data, and load data into these tables. Difference between data lake and delta lake. We're creating delta tables here. Relation to delta lake, features of delta lake, how to create delta table, DML operations, merging SCD type 1, type. Yes, sorry. Merge statements, handling SCD type 1, type 2, SCD type 1, type 2, handling data deduplications, handling streaming data that is in Delta Lake, workflows, reduction to workflows, creating run management, schedule Databricks, monitor Databricks. So in this, I didn't show you that in PySpark, a lot of data frame functionalities, that everything will be discussed, right? So from the basic to the advanced level. So if anyone, if you missed the test play session, right, you can just go through once the video of it. You can see in the chart, you can see in the chart, you can see that demo video, if you got a link for it, if you missed the yesterday session, right, got the demo video of that, you can see in that Zoom chat. You can go to that. Yesterday also I was discussing what is normal Databricks, Azure Databricks, just, and also you can see the course contents of this and the contact details of this. So just it was introduction to this Azure Databricks with PySpark. So from Monday, we'll be starting with the actual part, right? So the Monday, the link will be changing. You're supposed to get enrolled, right? To get the link to your mail IDs. And those who have already enrolled for Azure Data Engineering, you can directly attend the session. You can see that link to your mails. But who didn't enroll for Azure Databricks, check that. Okay, from Monday, step by step, everything will be discussing, right? Yes. So you can see that contact details, the payment details, the course content details, right? Yes. The timings of this batch will be same timing at 6 o'clock. You will be getting daily a video you will be getting. Even if you miss a session, right? So you should be regular to the sessions because everything, a lot of configurations you'll be doing here. You need to understand each and everything. So even if you miss any session, even the session is recorded, you will be getting the recorded video daily will be added to your Google Drive. Notes you will be getting every alternate days. And a WhatsApp group, a separate WhatsApp group for this Azure Databricks. Right. Any queries, anyone?
Sir, I have joined that complete batch Azure Databricks plus Azure uh, Data Factory. So will
Yes,
link will be
yes,
shared directly?
you will get the link. Also, everyone, you can copy that contact details. If you have not got it, you can call them, right?
And the videos drive link will be getting automatically.
Everything will be getting it. Otherwise,
Okay.
you can contact them. Contact numbers are given, right?
Okay.
Otherwise, you can intimate me. Okay, those who already got enrolled for Azure Data Engineering, Azure Databricks with PySpark is part of it, right? Yes, fine. Yeah, so yes. So daily, that same 6 to 7, the class timing, right? It goes for the next 2 months. So all the sessions will be interactive sessions. You'll be responding once we enter into this, right? Everything will be practical oriented. Nothing will be theory, right? Yes. Only for the basics, initial for the basics, right? I'll be discussing what are they. But later, once we enter into the practical part, once the cluster is created, everything we'll assign the cluster to the notebooks. We write the code in the notebooks. Multiple languages you can write. Python is the language that we prefer. So the basic Python no language. Just I'll brief you like in one or two sessions. I'll take right in taking the entire Python syntaxes before we are going with the actual practical part, right? Fine. So if I'm done with queries, I will sign off for now. Meet you on Monday. From Monday, we'll be starting with the actual things, right? Be regular to the sessions, try to interact, right? Fine. And try to do the practicals for the better understanding. Try to experiment and you can ask the queries at the start of the session, right? Yes. Fine. Okay, see that, okay, get enrolled if you're not enrolled to get that link to your mail IDs, right? Fine. So thank you all for your time. Thank you. Meet you on Monday. Fine.